Hi, this is Kat demoing the open source thermal cycler for the Hackaday Prize. This is our PCR setup. We have our heated lid, which generates heat through resistance. We PWM current through the nichrome wire, which generates the heat. Here's our thermal block. Though you can't see, it can hold 16 samples. Here's our Peltier. This both heats and cools our thermal block. It pumps heat from one side to the other based on voltage running through the element. These relays switch the voltage and thus switch the Peltier from heating to cooling when needed. Our PCB is controlled by an ATmega 32U4. This is the output for the heated lid. This is the USB interface. It sends temperature data to a computer which plots the thermal profile as the PCR runs. We have outputs for two buttons, a start button and a stop button. We have an output for a buzzer, which is used for debugging, and we have the input for the thermistor in the heated lid, which monitors the temperature of the heated lid. We have our display output, which is connected through a hex buffer. We have our thermocouple, which monitors the temperature of the thermal block, and the thermocouple amplifier. This is our screen. It displays the current stage of the PCR, the block temperature, the change in temperature, the runtime, the current cycle, and the analog reading from the thermistor. This is the temperature profile of our PCR. Up here you can see this is the denaturing phase, this is the extending phase, and this is the annealing phase. You can set the temperature within the code, but we're working on an encoder which will allow the user to input the temperature directly through a user interface. Thank you for watching. We hope you enjoyed learning about our PCR.